So as I mentioned, this objective can be, this is just an example to evaluate the risk associated with failure effects. That can be one objective, or it can be to develop a plan to detect, prevent, or mitigate those effects. So normally, the top one, that to evaluate the risk associated with failure effects are considered as the main. But please be aware, you should look at the second one, that the main objective, it is not explicitly mentioned in the project, but as a FMEA analysis person, your main objective is to develop a plan that how do you detect, prevent, and mitigate those effects, because keeping your end customer in mind, not only the immediate customer in mind. And in that one, especially in mission very critical industries, mission critical or automation or self-drive cars or uh, fighter aircrafts, other things, people do calculate fault isolation, like what is the source of the fault and what is the confidence. Is it 95% or 99% that you can isolate the fault in the system? And the other one is the fault detection rate, which tells us that normally they give as a requirement that if it is a critical failures or major failures or catastrophic failures, that detection should happen before the failure happens almost 99.999% of time. So that is an outcome of the FMEA, that you quantify that is it only 95% of time I can detect those faults or not. And then the second one, this test design, that's quite common. That's what we use in our product, general product design, that uh, when I have seen the design, I have identified the risk, and then we design accordingly that how do I test this product, that this type of failure, you try to stimulate that failure. And from the designer, if they have taken the proper action, that failure doesn't happen. So all the test design, or you prioritize that which system components you should be stressing more in your test, and which way you should be stressing that component. That's what comes from FMEA, that helps into the test design. There are other applications people do. There are other objectives can be like to give a maintenance plan, service plan, like you decide that when the car should be taken to the service every year after 5,000 miles, what should be done, or 10,000 miles, what are the parts or components needs to be changed. That comes as an output. You use the FMEA output to define those maintenance or servicing schedules. And this is very important in the aircraft industry, where they follow by later that which components needs to be changed within 200 hours or 100 hours. And then there is something else comes, the reliability centered maintenance. All those other things come to picture. They use the FMEA as an input to develop their long-term maintenance schedules for a product. And then other thing that earlier I was mentioning, the system boundary. Like the item which is system for me can be subsystem for someone else who is going to use that specific item, or maybe a component for them. Like I was saying, this bicycle bearing housing. If I am a bearing housing supplier, so it is system for me, but the company that makes the bicycle, for them it is a component, and then the analysis becomes different. When you look at the template, as a minimum, you should have functional block name, or you call it as a item or assembly name, like which item I am looking at, and what is the main function. And this function block, sometimes we can have the hardware, software, or firmware also. And then you look at what are the function of that specific functional block, which can be hardware, software, or a part of the system. And then since you don't know the design completely, so to identify the failure mode and cause, you have to bring in your designer and discuss with each item that how it can fail. And if you have a field returns, or if people have experience from those people who are involved in the servicing or repair or maintenance or aftermarket service, you should involve those people to identify those failure modes, because as a FMEA person, you will be not able to identify everything. So it becomes a group task. So you identify the failure modes and then the cause. There are some confusion between modes and cause, but that we can take over. You'll learn later on. Then from there, you go to what will be the effect of that failure. And normally these failures are people define as a local, intermediate, or end effect. And then this last two is always a challenge while applying this FMEA, that detection. How do we detect it? Is it some built-in test? Is it that some performance data parameter monitoring system that can signal me when it is deteriorating or not? Or is it just the visual inspection that will tell me? That's where you define your servicing cycle, like how servicing has to be done. Like you take your car once a year to look underneath if there is any rust, because you cannot detect it through any built-in test. You don't have it. But if there is a technology that you can do it, then you don't need to take it to the service center to inspect those parts. So detection is one thing. And then probability of occurrences, like as per the name itself, like how often that can happen. And that's a big controversy. And there you need a bit of experience about this area, that how do you decide this probability of occurrences? I will cover one example. And then the severity of how big is the impact of this failure. In general, this severity, the impact of a failure, is classified in 4 categories. This catastrophic, where it means loss of life. And then there is a critical, where it means personal injury. And then there is a major and minor. It depends on how big is the asset, how much you will lose. Will there be liability case, or will there be some other issues? So you take into that account, and then you categorize like 1 to 4. That's the way this MIL standard 1629 has done, but there are other way to do it. And then you multiply these 3 numbers, detection, probability of occurrence, and severity, to get your risk priority number. And once you have got the risk priority number, that up to here, when you come with it, then you have to plan your actions and other things. Those becomes a bit more challenging. So this is just an example how a basic FMEA should look like. So you have in the first column the part identification, or you can say a functional block name. This is done for one handset or old times mobile when you didn't have the touch. But you can, recently it was done for the ATM also, where you take out the money. Like metal individual key tops that you need to press to your pin when you're taking out the money. In the context of the mobile phone, it was like function was to enable typing text and dialing. And the potential failure mode can be the keys fell off, or the numbers written on the keys or printed on the keys. You can expand this one. This is just an example for one case. And what will be the effect? Users not able to identify keys, cannot enter text. And then severity of effect, that's where you have to define. Is it a scale 1 to 4, 1 to 5, or 1 to 10? this was done for the scale of 1 to 10, like what is the effect on the user, and the potential causes is the design related causes or it is the process related causes. So you can list all the causes in the same column, or some standards they want the cause should be in a different places, because when you are looking at the occurrence of causes, you are looking the different cause have different probability of occurrence. But sometimes you do this not for the occurrence of causes, you do the occurrence of the failure mode, like how often the keys can fail off. So you have to be careful what you are trying to do. Is it the occurrence of causes? You are trying to eliminate the causes, or you are trying to eliminate the failure mode itself. And then detection of the cause, like is there somewhere, like it's visually you can easily detect it. And then RPN is the, like you multiply these three numbers, 6, 8, and 5. That's the number you get. And in that way, you get a list of different failure modes, and you get the which one the highest RPN. And then you prioritize your action accordingly, that what should be the action and who will be doing the action by what date, and then what is the current status, open or close. And then you revisit this when some of these actions you regularly, periodically, you revisit these actions so that you can keep on updating this one. This is the one example where a simple keyboard and your computer. I have just taken the CPU side and the monitor. So you do a functional block diagram of that one, that keyboard, CPU. So if I'm when supplying to someone keyboard, monitor, and computer, I just put the CPU. Then this is a system for me. But the person who is supplying me the keyboard is the system for him, and he will break down the keyboard in a different blocks. Like I have broken down this system in these 3 blocks. And then the CPU manufacturer will break down the CPU into these 3 parts, 4 parts, or depending on what else he has a control unit or memory unit, whatever he has in that CPU. So whatever system you're going to analyze, you need to visualize or get a functional block diagram so that you have a picture that what is the system boundary, what you are looking at, what is their problem. Otherwise, it gets very confusing. So one thing more you need to be clear about this failure mode and causes. Sometimes the failure mode of a system may be the cause of the another system within that system. And the cause of the another system may become the failure mode of the another system. So the cause and failure modes. Here is an example that in this case, like blank monitor is caused by the LCD hardware connection failure. So the failure mode is the LCD hardware connection failures. That's the cause for this blank monitor. But the same thing, now this hardware connection failures can be caused by the corrosion. So here the cause is the corrosion and the failure mode is the hardware connection failure. On the top one, blank monitor is the failure mode and the cause is the hardware connection failures. So you have to be careful when you're doing a very complex analysis. Effects local, intermediate, and is either it will be overall system or overall on the user perspective, and intermediate is in between the system that you are studying and between the customer, whatever it is there. So local is the block, functional block that you are looking at, that it is like overheated, it will be not doing any processing, or it will not providing the number input, whatever functional block you are looking at. But the next system that uses the output from this local, that becomes the intermediate side. What will be the effect on the intermediate system or subsystem or component, which is usually the input from the local one. And the end effect is the two way you do it. You look at the overall system, or either you look at from the customer perspective. Severity, okay, as I mentioned, like is a catastrophic, critical, major, minor, but depending on what type of product it is, it can be either safety related or regulatory, like your product will be not certified or product will be not approved to be launched. There will be some legal reasons, and there can be some warranty related issues like cost wise. So what are the observations that we see, or is it the survey, other things? So based on the specific system, you categorize your severity in catastrophic, critical, major, and minor. But in a defense industry or mission system or mission critical systems, when you're launching the rocket or launching missiles, there it is like catastrophic, critical, major, minor. But this system, you can define this. What do you mean by catastrophic, depending on what system you're using? Yeah, probability of occurrence. This is just an example, like how you do evaluate the probability. Like this is the one case where I have taken, if the likelihood to happen 1 times in 10 use cases, then I will say probability is 10, very high probability. And this is something called, I had a field experience, field returns, and I can calculate the failure in time. And then MTBF, I could calculate this is something, the reliability. And then the failure rate was, it means greater than 5%. And the business wanted to bring the failure rate below 1%. They wanted the value to be 4. So we looked into this FMEA, and then we decided the actions. What are the actions that we should plan to bring it to the probability of occurrence up to 4? But that's where we should be focusing, like creating the plan to reduce those. Then again, this is the likelihood of detection. So again, there is a, sometimes customer ask, or it is industry understood that you should be able to detect the critical failures or catastrophic failures. So those which has got a rank of 10, you try it from the design perspective, figure out what can we do to bring it from 10 to 2 or 5. That depends on the business perspective, like how the business wants to use to see that how customers' satisfaction has to be experienced. And then as you discuss this, RPN, risk priority number, is the severity, occurrence, and detection. And then you have this, identify the actions. Either you do the redesign, depending on what is easy to do. Redesign, then you use a lot of quality tools for design for reliability, or you can use house of quality, other things to bring those, either one of numbers, this RPN number down, or what is the possibility of doing inspection, testing, maintenance. So there are a lot of other type of actions you take it to reduce this RPN number of different failure modes. And very important that you must evaluate this risk priority number after completing any of those actions, because then your scenario changes and then your priorities also changes. And you stop when this, you cannot go further down in the risk priority number, because either it is too expensive or it is a time or cost that makes you not to progress further. But one should always document at that stage, so that when you have the new variant of that product, then people know what are the possible things we should have done. Then they can do it from the very beginning of the product. So in general, as a summary, You are here now, this flowchart type of things. The main actions is that you should have objective and a scope, and then you build a cross-functional team to identify and rate the RPN, the initial risk, and then you go through this. Is there any risk to be mitigated? You plan action, take action, identify action, and then you stop FMEA when it is not feasible for them. This is just a difference between fault tree and FMEA, where FMEA go horizontally, like you start the part or functional block, function failure mode effect causes. Fault tree starts with the end effect, and then it looks what is the causing that effect. So it's like a tree. From the top, you go down. So this is just the same thing like blank display and hardware connection failures, PWB pad is defective, why it is defective. So you keep on, at least people try to do it 5 level down. And that's what it is summarized in the FMEA. So it depends on what's the purpose objective. Should you use the fault tree or FMEA? That's what it will decide. So as I think throughout my speech, I have mentioned that what are the different challenges that we face while applying this one, like objective and the scope of FMEA are not clear. Many industry forming cross-functional team. These are practical problems that you face, like focusing only on the known problems, not unknowns, and unknowns remain unknown unless until you brainstorm thoroughly these things. Sometimes they do very late in the design. Sometimes they consider only one of activity. That is the biggest challenge that I see. And then defining the rating scales, depending on your skill, your experience, you can become better day by day to do it. Yeah, job opportunity wise, reliability engineer, quality engineer, maintenance engineers, manufacturing, safety engineer, FMEA engineer, failure analysis engineer, or R&D project manager, or if you're in the finance side, so implementing any different way of service, of you're in the health sector side, what are the equipment that you are going to use, how you are going to use. So it's not only the engineering side, it's a medical, finance, other areas that you use these ones.